All right, after taking a short breather to work on vocabulary and make sure we were doing all right with our concepts so far, we are back with day 7 and once again, another day dealing with angles. And you can see that that word angles is everywhere. Our entire first standard, all about angles. All 4 of those concepts have to deal with angle pairs and how we use them to solve problems. And then distinguishing between segments and angles, once again, angle bisectors, segment bisectors. We know that word bisect, if you remember from vocab, means cut in half. And once again, we're talking segment addition postulate, seg add post, versus angle addition postulate, angle add post. And of course, one has to do with line segments, and the other has to only do with angles. And so we're going to switch things up a little bit today, guys. Today is not a super heavy uh, working problem, long equation kind of day. Today is very definition heavy and then applying those definitions. So what we're going to do is I'm going to give you, just like on Friday where I focused on vocabulary, I'm going to give you some time here. And I want you to focus on, really to start, I want you to focus on these first 3 definitions for me. And I want you to label if you need to, maybe make an example over to the side, but give yourself some room because whenever I unpause this video, I'm going to kind of show you how a lot of these definitions work and what exactly they look like. So you can go ahead and pause the video and read over those now. Now that word adjacent, some of you guys may not be super familiar with that word, but that word adjacent means right beside. So when you're adjacent to something, that means you are right beside it. And so looking at this example here, what are some angles we could say are adjacent? Well, angle 1 and angle 2 are adjacent. They're right next to each other. How about angle 2 and angle 3? Right next to each other. That's all adjacent means. They are on the same plane. They have a common vertex and one side in common, like angle 1 and angle 2 have this side in common and the same vertex, but they don't have any interior points. All the interior points for angle 2 are in here. All the interior points for angle 1 are here. No common interior points. Here's going to be a big one, and this one can save your life if you recognize it. Vertical angles. We're not talking just straight up and down. That's not exactly what this means. These are 2 non-adjacent angles, so angles that are not right next to each other, not exactly on the right, not exactly on the left, but they are formed by the same 2 intersecting lines. The same 2, if they have the same 2 lines in common and the same endpoint forming these angles, that means they are, here's the key word, they are congruent. Vertical angles are always congruent. Always, always. And check it out. Angle 2. What non-adjacent angle is formed using those exact same 2 lines that would make it a vertical angle? That's right, 4. This line and this line form both that, and they're not next to each other. 1 is next to 2, 3 is next to 2, 4 is not next to 2. It is on the opposite side of this vertex. Is there another pair of angles here? Yeah. 1 and 3. Same vertex, opposite sides of this vertex with the same lines creating both angles. That's a huge one. How about a linear pair? These are a pair of, there's that word again, adjacent, beside each other, right beside each other angles, whose non-common sides are opposite rays. So check it out. From B to C, that is a opposite ray compared to A to B. And this ray right here splits these angles up but puts them right next to each other. to create a linear pair. So we could say angle 1 and angle 2 are a linear pair. Okay, here are two that I'm hoping you guys have seen before. You just maybe get these confused sometimes. Complementary angles and supplementary angles. Now there are a couple kinds of these, but they usually have they have one big thing in common. A complementary angle are two angles that measure up to be 90 degrees. We see it here, 30 and 60. That creates a 90-degree angle. Now here, be careful. Two different angles, not attached, but they are complementary. 40 plus 50 is still 90, but they're not adjacent. So be careful there. These are not adjacent because they're not connected with the same vertex. And then as far as supplementary angles are concerned, let me zoom in a little bit here. These are two angles whose measures are 180. And again, you have a lot of different kinds of examples here, but I want to take you back to the linear pair postulate. Now, we mentioned linear pairs earlier. A linear pair can be formed if two angles are next to each other, but here's the thing. If two angles are a linear pair, they are also supplementary. If two angles are a linear pair, then they are supplementary. This does not work the other way. I'll even write that out. This does not work the other way. A linear pair will always add up to be 180 degrees. We see that up here. But a supplementary set of angles will not always be a linear pair. Check it out. Now, these two don't add up to 180 at all, and they're not connected. That's not either. But look at this. This is a supplementary set of angles. 120 plus 60 is 180, but they are not connected. They are not adjacent. So they are not a linear pair. But if you do have a linear pair, absolutely going to be supplementary. Now, we only have 3 definitions left for today, guys, before we start putting these definitions into action. And 2 of these, maybe all 3, you will have seen before, especially this next one. Perpendicular lines. We know these are lines, rays, or segments that intersect, but here's the key. They intersect to form 4 right angles. If these 2 lines don't create 4 right angles from their intersection, these are not perpendicular lines. We need a right angle there, 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 and there. And so let's call these lines, we've got A and B. Here's how we can show this from a geometric perspective. We can say that line A is perpendicular to line B, and the symbol we use to represent that is an upside down capital T. We draw one line connecting to another line. It's like an upside down T. So if you see this symbol right here, that means perpendicular. So line A is perpendicular to line B. It's a lot quicker and easier than having to write out the word perpendicular, isn't it? Now, next up, we've seen something very similar to this one right here. In fact, we've done, I think, a math problem kind of involving this before. The angle addition postulate. Very, very similar to seg add post. We know that if you have one angle adjacent to another angle, then these 2 angles added together, part plus part, equals the whole. So angle ABC plus angle plus angle CBD would add up to be the whole angle of ABD. You can see that down here. Part plus part equals whole. Last one for definition. The protractor postulate. Sometimes I have a hard time saying that word. We know that if you're dealing with a basic geometric shape, non-circular, no polygon, we're not talking squares, rectangles, just an angle, right? Just one angle, no circle, then that angle is going to fall. It's going to be less than or equal to 180 degrees, but it's going to be bigger than or equal to 0 degrees. It's going to fall somewhere on this spectrum. All right. Now you guys get to put this into action. Check it out. I'm going to let you guys take a moment and be careful as you label 1, 2, 3, and 4. Know that a couple of these are actually going to have 2 right answers. So a couple of these are going to be more than just one thing. So you can go ahead and pause the video and see if you can label these 4 pairings. Okay, so I've got the first 3 revealed here. Take a second. Anybody go 3 for 3? Angles 1 and 2. Those are adjacent, right next to each other. We see though not a linear pair, not supplementary, right? Because these 2 aren't going to add up to be 180 degrees. 1 and 4 are vertical. That means these are really the same angle. They have the same endpoint or the same vertex, and they use the exact same lines to create their angles, but they are not right next to each other. Vertical angles. 3 and 4. Number 3 is where things get a little interesting. Number 3 and 4 are complementary. So this angle plus 4 is going to add to be all 90 degrees. So complementary, and they're adjacent. They're right next to each other. 3 plus 4 is complementary, 90 degrees, and they're right next to each other. How about number 4 here? Angles 4 and 5. Well, let's see. They're right next to each other. So we know they're adjacent. That's one thing. Let's see. 4 and 5. Ooh, wait, is this a straight line? Yeah. And these are the only 2 angles on this side of that straight line. So angle 4 and angle 5 being right next to each other, and they create a straight line. These are a linear pair. And what do we know if these are a linear pair? That means they're supplementary. So check it out. That one was actually 3 different combinations here, 3 different kinds of pairings. So always be on the lookout. That's why it's so important to get these definitions down and kind of keep track of them. So take a moment, guys. Read over number 5 for me, and go ahead and see if you can just label what we've got here in the picture. If you feel like solving, you can, but you can also pause and wait, and we can work it out together. So hopefully you were able to get some things labeled here. And here is the key. We're obviously going to want to find out what x is. And by finding x, that's going to help us figure out what this angle is, what this angle is. And really, don't we already know what angle WOZ is going to be? What do you see right there? Yeah. We're told that and that are complementary. That means WOZ we already know is a 90-degree angle. But because of that, what can we use to help solve for x? If this whole angle is 90 degrees, couldn't we bust out part plus part equals the whole? So we can say, okay, 19x minus 26, that's this first angle, plus 10x, our second angle. This should equal the entire angle, the complementary angle, in fact, 90 degrees. And so, guys, you can pause and just work this out for me. Let's see what we end up solving for x. Okay, so when I combine like terms, add that 26 over and divide by 29, I got x equals 4. Okay. That's going to make it pretty easy now. That's a smaller number. If I plug that back in, we see now that you plug 4 in, 10 times 4, oh, that's just 40 degrees right there. And if you plug 4 into this top angle, 19 times 4 is, I want to say 76. Let's double check. Yep. And then subtract 26, you get 50 degrees, which makes sense, right? If this is a 40-degree angle, what do we know this other side has to be if it's all going to be 90? 40 plus 50 will give you 90. So we now know WOY is 50 degrees and YOZ is 40 degrees. Last page. But what that means is, that means we're moving kind of quick. So guys, if you have any questions at all, again, you can email me. You can send a remind. Just try and make sure you're getting in contact with me if you're ever confused at all. And the reason I say that is because since you're my accelerated class, sometimes we're going to come to a problem where I'm going to see where you're at. I'm going to see if you're really getting this or see if maybe you're struggling a little bit right now. And number 6 is going to be one of those problems. The one hint I'm going to give you is that obviously we have a straight line here, so 180 degrees, and we only have 2 angles to add up to be that 180 degrees. So my little secret for you is that we have a linear pair. And from there, guys, see if you can find out what X is, see if you can find out what PQR or PRQ is and what QRS is. You can pause the video. I'll unpause for just a second, just to make sure we're on the right track here, guys. Now, why was I able to add up both these angles and set it equal to 180? Well, because this is a linear pair, which means these 2 angles are supplementary. They're going to add up to be 180 degrees. So I'll go back to pausing the video, and you guys can finish the problem. All right, you take that 19, you plug it back in, and you get yourself 127 degrees and 53 degrees. So if you're feeling pretty good on those, guys, then if you're feeling good on that problem, you should be feeling pretty good about this day. And so our last section is going to see us doing a little bit less math, but a little bit more logic. So on this section, we're going to do 2 things for me. I want you to state what kind of angle relationship or relationships we have. There may be more than one. And because of that, I want you to then be able to find the measure of our missing angle. So I'll do a couple with you here. Let's look at number 7. So number 7, we've got, looks like 2 angles, a straight line, so we know 180 degrees. And so what's something you guys could tell me about number 7? Well, you could tell me this is a linear pair. 2 angles make up a straight line. You could tell me these 2 angles are adjacent to each other. You also could tell me that because we have a linear pair, these are supplementary. That plus that is going to be 180. And so because of that, what's that going to mean for B? If this angle is 50, subtract 50 from 180, angle B's got to be 130 degrees. And so I'm going to let you guys try 8 and 9, and then we will come back together to talk about number 10. We'll get a little homework with our multiple choice, and we'll be ready to wrap up. So you can go ahead and pause. So just to check yourself here, number 8, vertical angles, not adjacent, same vertex, same lines create these angles. So that's number 8. Number 9, these are adjacent, they're right next to each other, and we also see that they're going to add up to be 90 degrees, so they're complementary. That makes B 27 degrees. And to conclude today, guys, I want you to take a look at this problem. This is going to be an interesting one. In fact, this one we see based off 209. This one breaks the protractor postulate. So we're going to have some angles bigger than 180, obviously. And in fact, what do you notice this is forming right here? That's right. This whole thing is going to be a circle. And what do we know as far as the amount of degrees here? What do we know about the amount of degrees in a circle? Well, you may have forgotten, but a circle has 360 degrees in total. Now, we see 209 represented here. We see 96 represented there. And so what are you guys thinking we can do to solve for B? If we have these two other angles that we're looking at that are next to it, what property can we use here? Or what postulate? That's right. We're going to bust out angle addition postulate. Ang add post. And what that's going to let us do is that's going to let us say, okay, we know that we have 360 here. So 209 plus 96 plus B should equal 360 degrees. Part plus part plus part equals the whole. And so we add these together. Let's see. 209 plus 96 is going to be 305 degrees plus B equals 360. You subtract 305, and angle B is 55 degrees. So if you have any questions at all, guys, make sure you get in contact with me. Again, you'll be able to get on Google Meet at that 30-minute mark if you are an online student. Or if you're in person, you'll be able to ask me. So thank you very much, guys, and I'll be talking to you soon.